Assalamualaikum and salam sejahtera. My name is Hamad Akif bin Yahya. My metric number is 01DKM21F1132. My fellow groupmates and I will be presenting application of differentiation and stationary. Firstly, let me begin by introducing my group members and their role for this presentation. Up first is Muhammad Fahmi bin Nur Shaidan. Metric number 01DKM21F1143. He contributed by brainstorming with the group on the direction of this presentation and found photo to be used. Next, Muhammad Shazwan bin Nasharuddin Sulong, 01DKM21F1149. He contributed by setting up the PowerPoint and translating it into English, as well as doing his part on this question given. Finally, we have Muhammad Khairul Iskandar bin Rasidi, 01DKM21F1150. He contributed by finding our sources to cite and to double check the equation that we did. Without any delay, let's head to the next.
Now, let's begin with differentiation. What is it used for? Well, differentiation is used to calculate the rate of change of anything really we can. View it as rate of change of x with respect to y. And as you can see from the photo, there are 5 different types of rules for differentiation, and it can also be used to calculate the gradient of a slope. A very common calculation using differentiation is velocity with respect to time, written as dv over dt. Now, I let my friend Shazwan show an example of the real-life application of differentiation.
Thank you, Iskandar, and now I will show how a person were to use this equation from the question. Let's say a manufacturer wants to make a cylindrical can to hold 250 pi centimeters squared of soup. We need to find the dimensions such that the surface area is as small as possible so that the cost of the can is also as low as possible. Now, let's start with the formula of volume for cylinders, which is pi r squared h. To find the surface area, the equation will look like 2 pi r squared plus 2 pi r h. And the reason why it is because we have two circles, top and bottom, which the formula for a circle is pi r squared, which makes it 2 pi r squared. Now, the only value that we are looking for is h, which is height. Going back to the volume formula, we swap the values around and our equation will be h equals to 250 pi over pi r squared. We cancel pi out and we are left with h equals to 250 r squared. This is a temporary value for h now, so we bring it to the surface area equation and it will become 2 pi r squared plus 2 pi r times 200 over r squared. Now that we have our new equation, let's try to solve it. Let's begin on the right side by completing the parentheses or the corner. The 2 pi r times 200 over r squared equals to 500 pi over r. Update the equation. Now is 2 pi r squared plus 500 pi over r, which can be written as 500 pi r to the power of -1 because it is divided by r. Now, we can't really do much after this equation, so here is where we use our differentiation. We write it down as dA over dr. Because we are differentiating a with respect to r, we take the powers of both 2 pi r squared and 500 pi r and minus each of them by 1 and multiply them to their corresponding number. With that, we get 4 pi r minus 500 pi to the power of -2, because again we are reducing the value of power by 1. Now that part is done, we move on to the final step where the derivative of y is taken with respect to x, which in our case a taken with respect to r. Right now we are finding the rate of change equals to 0. So we write down dA over dr equals 0. Next we get 0 equals 4 pi r minus 500 pi to the power of -2. We bring 500 pi to the power of -2 to the left hand side, divided by 4 pi because we are trying to find r. We will get 125 over r squared equals to r. bring the r squared to the right side. That will be 125 equals r cubed, or to the power of 3. Final step is we take the power of 3 and bring it back to the left side, resulting in cube root, which is 3, and then the power of or 3 to the square root. And our final answer is 5 equals to r. Now we have the value of r. We substitute that value to h equals to 250 over r squared. That will be 250 over 5 squared, which is 25, and divide it normally, and h will be 10. But wait, is this equation true? How will we know that it is the lowest that it can go, or minimum? We can prove whether it is the absolute minimum by differentiating it again, called second degree differentiating. It is written as d squared a over dr squared. And all we have to do is simply minus the powers of r by 1 again, or differentiating it again. Since 4 pi r doesn't have a power 2, we remove r, and 500 pi times negative 2 is 1000. It went from a minus to a plus because negative and negative is positive. And now we substitute the value of r to 5. Now we have 4 pi plus 1000 pi divided by 5 cubic, which is 125. 1000 divided by 125 is 8. Now we have 4 pi plus 8 pi equals to 12 pi. Now 12 pi is obviously larger than a 0, and by the axioms or rules for second degree differentiating, if a value is greater than 0, it is a minimum, and if it is lesser than 0, it is the maximum point. Now with 12 pi being greater than 0, we can now say that it is the minimum point, and this is the smallest height we can get to. Now here's another question, but with graph now. The question states that the graph of a curve with equation y equals x cubed plus 3x squared minus 9x plus 6. We need to a. Use differentiation to find the expression for gradient of curve. B. Find the coordinates of any stationary points on the curve. C. How many stationary points does the graph have? D. Determine the y-intercept point. E. Determine the nature of any stationary points you found in part C, justifying your answer. And finally, F. Sketch the graph of the curve. Now it is the same concept as earlier, only we need to add a graph at the end. So let's begin with question A, B, and C with me, keeping up the rhythm and cadence here. Now we have the equation as y equals x cubic plus 3x squared minus 9x plus 6. If we differentiate it, we will get 3x squared plus 6x minus 9. If you're familiar, you recognize this as a quadratic equation. So we need to factorize them, and we will get 3 parentheses x minus 1 and parentheses x plus 3. So for a stationary point, dy dx equals to a 0, so we bring out both parentheses and they both will result in a 0. To find x, we bring negative 1 and 3 to the right side, negative 1 and positive 3 to the right side, and we will get x equals to a 1 and negative 3. Now that we have 2x, we will substitute both of them to our equation earlier, the 3x squared one, and in the end, we will have y1 and 33. Now we have both x and y, which means we found the coordinate, or stationary points in this case, which are x1 and y1, and x negative 3 with y33, and that this graph have 2 stationary points. Question D. Determine the y-intercept. Now this concept is actually very simple. If the graph intercepts at the y-axis, then the x-axis must always be a 0, because the graph is colliding with the y section or intercept. Therefore, we substitute the earlier equation with x equals 0, and we will get 6. Then we will get the y-intercept of 0, x0, and y6. Question E. Determine the nature of stationary points in C. Now there are 3 natures of a stationary point: minimum, maximum, and inflection. To determine the nature of the stationary points, we must use second degree differentiation, as from earlier, which in short is to differentiate the previously differentiated equation again. So let's begin with dy dx being 3x squared plus 6x minus 9, and we multiply 3x by 2, removing the square, 6x turns into 6, losing the x, and 9 will be 0. So we will not put that in the final equation. We are left with 6x plus 6. And now for second degree differentiation, a minimum point is if the equation is greater than 0, there's a minimum point. If it is lesser than 0, it will be a maximum point. And if it is a 0, it will be a point of inflection. Now we simply substitute both values of x, where x is 1 and negative 3. We will find that x1 is a minimum point and x negative 3 is a maximum point. Now final question is to sketch the graph, and from what we can see here, the maximum point is indeed on x negative 3, and the y-intercept is on 0, x equals 0 and y is 6. And finally, the minimum point is on the coordinates where x equals to 1. And for now, we are sure that our earlier equations and calculations are correct. And that will be it from me, and my friend Fahmi will summarize our presentation.
Hello, my name is Muhammad Fahmi bin Syaidan. I'm from DKM2. My registration number is 01 DKM21F1143. In short, derivative is a very crucial part of mathematics as it is applied everywhere from business to a policeman using a radar gun. This concept, named applied mathematics, is a cornerstone of our society, and we must learn how to use derivatives as a means of efficiency in calculating change, whether from chemical reaction to maybe even maximizing profit in a business. Thank you.